All right. That A and that A are the same thing, right? Now, if I want to evaluate, I need to replace this A with what it's equal to. Okay, that's what substitution means. Replace something with what it's equal to. Same thing with my B. This B here is that B. So instead of writing it as B, I'm going to write it as 5. So 3. Now, there's no symbol between the 3 and the B, so what are we doing there? What operation? Multiplication, right? Now, if I don't put a symbol between the 5 and the 3 now, it looks like I just wrote 35, right? Okay, instead of what should be 3 times 5. So what I like to do, and I do this all the time, whenever I substitute something inside an expression, if it's multiplication or division, I'm going to put parentheses around it, okay, just to make sure that I indicate to myself what I'm doing, okay? I didn't necessarily do that here with the -4. I think it'd be kind of silly to put an extra set of parentheses around this -4. But that's how I'm going to operate, okay? So now, what we do is we go through our order of operations. So our order of operations, okay, and I always underline the M and the D and the A and the S just to remind myself that they come as a group and I got to do them together. I'm going to go parentheses. So what that tells me is look through here and find any parentheses that I can work in, okay? Now, sometimes there's another set of parentheses up there, but the other set of parentheses that are up there is identifying an operation of multiplication, right? It's not identifying anything. Their purpose is for multiplication. So basically when we say parentheses, we're looking for things that are being grouped. Parentheses are grouping symbols, okay? So we're grouping those. So now I got to do my order of operations in there. So once I highlight, now I'm focusing only on that. So essentially what this means to us is that we are going to mentally block everything else out. Mentally, nothing else in this problem matters. And for some reason, it doesn't want to disappear. All right? So nothing in this problem matters anymore. Okay? I'm just going to look at what's inside those parentheses. And now I'm going to start back over at the beginning in the order of operations and go parentheses again. Are there any parentheses inside those parentheses? No. Okay? So I go to exponents. Are there any exponents? No. Multiplication, division together, left to right. Is there any multiplication or division in there? No. Add, subtract, left to right. Is there any adding in there? Yes. And the adding, those things, what did we call those things yesterday when they're opposites like that? Not reciprocals. Additive inverses. Okay? So we're adding, so we're additive, and they go to 0, so they're inverse. Okay, so we're going to, what the heck? There we go. That's going to go 7. And then this turned into 0. So I'm just going to fix, or I guess I'm going to call it evaluate the one set of operations that we did. Everything else stays static or does not change. It's just carry it straight down. Okay. Now that I've got this line, it's essentially a new problem now. Now I'm going to go through parentheses, exponents, multiply, divide, add, subtract again. Okay. Now, as I do this, I look at parentheses. Now, I do have parentheses up there, but there's nothing inside those parentheses that I can do work with, right? Does that make sense? So look at that first set of parentheses around the 0. Look inside the 0. What can I do with that? I can't add it, subtract it, or anything else that's inside there. Okay? So those symbols there, those parentheses, are just representing an operation of multiplication for us. So no parentheses that I can do work in. Go to exponents. Are there any exponents? No. Multiply or divide, left to right. Is there any multiplication? Yes. So the multiplication occurs right here, right? Left to right, that's the first instance. So what's 0 times 7? 0, right? Now, traditionally, in my example, I would write this, and that's the only thing that changed. Okay. Now, some of you might say, well, I'm going to do the next iteration of multiplication at the same time. But if anybody put the 0 down and then also put the 15 down, that makes sense? You could do that at the same time. That's fine. Okay. But if we're going off of doing one thing at a time, I'm now going to write this down, and I'll go run through this again. No parentheses, no exponents. There is multiplication division. So I'll have 0 plus then this turns into 15, and then minus 8. Okay. So now I'm going to run through again. There's no parentheses. There's no exponents. I've exhausted multiplication. I've exhausted division. Now I'm going to add and subtract. So add and subtract says do these two things to get the left to right. So do those two things first. So it gives me 15, right? And then minus 8. And I go through order of operations, start parentheses, no exponents, no multiplication, no division, no adding, but there's subtraction. So it gives me a total of 7. So I've evaluated, and I come down. I started with something that was pretty complex, and I've dwindled it all the way down now to just one singular value. Is that okay? If you're a person that doesn't need all of those steps, and you're going to say at this juncture right here, you're going to go down and say, okay, I know, well, 7 times 0 is 0, plus 15 minus 8. And then you're going to say, okay, 0 plus 15 minus 8, that's 7. If you want to do that, that's fine. But if you're a person that does it, if you're going to combine steps, okay, and skip some writing of things down, and you get answers that are wrong, should you continue using that approach? No. Okay? So that's always something to be reflective of your work, be reflective of your answers. If I'm getting something wrong all the time, then I got to change my approach. Okay? And maybe you got to be more deliberate with the way you write stuff down. Okay? Yes, question. So you just did mental math. Yeah, that's okay. That's okay. The one thing though, if you understand your mental math, that's fine. But if you, like I say again, if you're coming up with a lot of errors, you need to write stuff down. Okay. Especially let's say you have a bunch of errors, but like you're showing me like one line of work there, and you come to me and say, where am I going wrong here? I can't see in your mind what your steps were, right? But if they're written out, structured out on your page, it's not that bad. There will be times, guys, that we in class. I know probably most of your tests last year were they online, were they in Math Excel? Because there's only 9 of us, we might. I forgot we got 12 at home. Never mind. Okay. If I ever give you an assignment that is by hand, okay, and you have just that one line of work and it says like 12, but the answer was 7. I don't have anything I can grade, right? I can't go back and say, okay, here's your error. Maybe you missed a sign somewhere, and I can give you, if that question's worth 5 points, I can give you 4.5 points for it. But if you have essentially no work or very limited work, and your answer is completely off, I have to give you like a 0 out of 5. Does that make sense? So more work when I'm reading work, the more liberties I can give you in points. Yes. Yeah. All right, so here we go. Next one. What's that? All right, so the next one is x over 2 plus y squared if x is 1 and y is 1/2. Okay, so this is going to incorporate some basic laws of exponents that maybe we've talked about in the past. But I'm going to substitute. So I'm going to take my x equals 1, and I'm going to replace that x right there with it. So I get 1 over 2. Plus then my y, which is 1/2, and I'll replace that y with 1/2. And it becomes squared. When I replace, especially when there's exponents involved, I want to make sure that I put parentheses around what I substituted in. Okay, especially if what's in those parentheses, what I'm substituting, is like a fraction, or maybe it's multiple terms. Maybe it's like another variable term or something like that. I got to put it in parentheses. Okay, so what does this mean to me? Okay, I'm going to go through PEMDAS. I'm going to go through order of operation. So are there any parentheses that I can look through here in which I can do work inside of? And there are parentheses here, but are there any operations inside those parentheses that I could do? Any adding, subtracting, multiplying, dividing, any more parentheses or exponents inside there? So those parentheses are not standing in for something that we need to do to focus our attention on. The next thing we'll look at exponents. I do have an exponent, right? Okay. What does that exponent mean? What does 1/2 squared really mean to us? Like what if I said like a squared? What does that algebraically mean to me? A times a, good. So 1/2 squared means 1/2 times 1/2, right? Okay, which would be, okay, so it's 0.2, so it is 0.25, but because we're going to evaluate and I want to keep things in the structure that we have here, I'm going to write it as a fraction. So I multiply straight across the top, which is 1. Multiply straight across the bottom, which is 4. Okay. Now here's my question. Think about this, and this is a law we should have learned in Algebra 1. I know that was a while ago, but if I have 1/2 squared, and you just told me, well, that means 1/2 times 1/2, right? And by multiplying fractions, we know that that turns into 1 times 1 up top, 2 times 2 on the bottom. How can I rewrite that? What's 1 times 1 the same as? 1 squared, isn't it? What's 2 times 2 the same as? 4, but I'm going to write it as 2 squared just to prove a point here. Look at what I started with, and look at what I get. So 1 squared is the 1, 2 squared is the 4. But do you see how I can go from this here to the answer quick? It just means all I had to do was I take that number right there, and I square it. I take that number right there, and I square it. Does that make sense? So when you take a fraction and raise it to an exponent, you basically raise the numerator to that exponent, raise the denominator to that exponent, and you've got your evaluation. All right, how do I add two fractions? What do I need to combine fractions? Can I just add those straight up and get like 2 over 6? How do I add these? What do you need? Common denominator. Okay. So what is the common denominator going to be here? 4. Okay. Common denominator just means it's a number that that both denominators can grow to using multiplication. So how do I make 2 grow into 4? Times by 2. Okay. Now when I do that, if I just multiply the bottom by 2 here in this fraction, it changes the fraction to 1/4. I just took a half and made it smaller, right? I don't want to do that because I want to add 1/2 to 1/4. So what do I need to multiply the top by? 2 as well. So what did I really multiply by? What's 2 over 2 the same as? 1. And multiplying by 1, 1 is the multiplicative identity that we talked about yesterday, right? So multiplicative identity means it doesn't change. It might change the way it looks, because you're going to change this to 2/4, but it doesn't change its amount. So now what do I get if I add those? Once I have a common denominator, what can I just look at? Yeah, I can just do the addition of the numerators. So it gives me 3, right? And I put it over the denominator of 4. In my opinion, and I've voiced it, and obviously state legislature doesn't care what James Fay thinks, or Jim Fay. Okay, so I've voiced this opinion to my colleagues and teachers in middle school and everything. My thought is like middle school should be like we should teach socialization, reading, and like your basic math facts. Okay, they get into stuff in the middle school that like if they had basic math facts like mastered by the time they got here, like I could teach some of that stuff in like 20 minutes to people. Okay. But sometimes when we're substituting here and evaluating, This process is a lot easier if we automatically understand how to add and subtract fractions, right? Okay, but people through Algebra 2, through higher level classes like Algebra 2, struggle with what we're currently working on because their foundations of adding, subtracting, multiplying, dividing, and working with fractions is limited. That's something that I hope we build on in this class is that just collectively. I talk to my college algebra students who, they've had algebra for 3 years. This is their 4th year, and they still struggle with adding and subtracting fractions, stuff like that. So those are things that I, as a teacher, know is a problem, and we're gonna focus on them and make sure that we get them worked out. But I think just education. I think if we all could learn to read better and do basic math facts better, once you got to high school would be a breeze. But you think about a lot of the things that you sit and do in school, you're trying to get better at reading while you're trying to work on something in history. You're trying to get better at adding, subtracting, multiplying while we're trying to do something a little bit more difficult in mathematics. And it just creates unnecessary, I think, work and stress and that kind of stuff. All right, next example. Let's evaluate this thing. So now we've got, we call this a rational expression because it's a giant fraction. But we're just going to replace our parts. So we get 2, and then the x becomes 6. So it'll be 6 squared. Minus then the y becomes, now, when I replace a variable, so I'm replacing, so this minus here has to stay. Does that make sense? Okay, you never, and in an expression, you never alter the signs that start out. If I'm going to take y and replace it with -3, I want to do it this way. I want to make sure that I replace in parentheses that way. If I don't do that, I'm going to run into an error, and I'll show you what I mean when I grab my calculator. Okay? You guys have maybe experienced this in other classes. Maybe your other teachers have shown you this. If I take my calculator, and this is the type of stuff that I talked about earlier in regards to these things not being very smart. If I plug in -3 and I square it on my calculator, does anybody know what it's going to give me back as an answer? I want to do -3 times -3. What is -3 times -3? Huh? What's negative times a negative should give me a positive, right? And 3 times 3 is 9, right? So it should be positive 9. Gives me negative. Why does it give me -9? No, it's because this thing knows its math facts to a T. It's been programmed to follow the order of operations to a T. And the order of operations say that an exponent is applied only to the object that it is directly behind. There's 2 objects up there. There's a negative and a 3, right? And we can view it as like -1 times a 3 squared. Does that make sense? Huh? That's wrong. So what we need to do, and this is why I wrote it this way, what we need to do is this. I want -3 squared that way, because that's going to take -3 times -3. And that gives me the 9 I want. But if I don't know how my calculator works, and I don't understand the order of operations, and I don't focus on that stuff when I'm writing stuff down by hand, when I try to use my calculator to help myself out with something, I'm going to make that error. Okay? Interesting. Hey, it's my job. All right. So now I'm going to look at order of operations, so parentheses. We've got something going on in the parentheses, right? Okay. So I'm going to look at those, and now the question is, are there any other parentheses inside this? So like we said, we start with parentheses, we narrow our focus. So I'm narrowing my focus, I'm just looking at that stuff right now. Are there any other parentheses in there that I can actually work with? Okay, so that's where I'm going to go, but it's not because I can do work inside these parentheses, right? So what I'm trying to say is, like, let's look at something like this. Let's say I had like 2 times 6 squared minus -3 plus 4 squared all over 3. if I look at my parentheses, so this is parentheses, right? Does that make sense? So I'd focus on that. And now I'd ask the question, well, are there parentheses inside those that I can actually do some work? Are there more parentheses here? Does that make sense? So then I would basically focus solely on that, do the work there, and then work my way back out of those parentheses. Does that kind of make sense? But there's nothing in that parenthesis right there. There's no other operations happening inside that -3. So you are right, though, that once I've focused my attention on the stuff that's in blue, once I focus my attention on the blue stuff, I can now run through order of operations again. There's no more parentheses, but there is an exponent. Okay, and there's a series of them, right? So we can address them all at the same time. What's 6 squared? 36. That minus sign has to stay. Okay, now what's -3 squared? 9. Okay. All over 3, correct? Now, if I didn't put in, think about this, if I didn't put in this set of parentheses right here around that -3, I would have squared just 3, which would have given me 9, and I would have had minus a -9, which turns into a +9, and I have 36 plus 9 in those parentheses, which is not what we want. That's not the right answer. So now we've evaluated that, we've rewritten, and I got to go through this again. Are there still parentheses? Yeah, so I'm going to focus on the parentheses. I'm going to do the work that's inside there. What's 36 minus 9? 27. And then divide by 3. Okay. So now I'm going to go parentheses, exponents, multiply, divide, add, subtract. Okay. Something that I guess we didn't really mention right off the bat is when we have fractions written this way where you've got this long division bar, that long division bar operates as kind of like parentheses. And the fact that you can do everything in just the top as one separate problem and keep working with just the top until it comes to one value. And then you can do the same thing with just the bottom and keep working with the bottom until it's just one value. Now, I didn't mention that right off the bat because the bottom is kind of trivial. There's no work to be done down there. But when I get to 2 times 27 all over 3, the question is, well, do I do multiplication first or do I do division first? Well, because we're reading the top, we're going to do that multiplication first. So what's 2 times 27? 54. So I'm going to rewrite this as 54 divided by 3. 54 divided by 3. And there's my solution. Okay. Now, eventually, because of what we maybe know already with our fractions, is 2 times 27 over 3. Can I rewrite that as 2 times 27 over 1 times 3? Is that okay? If I multiply those together, do I still get 2 times 27 and on the bottom 1 times 3? Is that still 3? So this is an equal version of this. And why I would do that is maybe I can see that. What's 27 divided by 3? 9. What's 9 times 2? 18. So over here we have options. I said I'm going to take the numerator, 2 times 27, make it 54, then take 54 divided by 3 gives me 18. That's the most, I think, maybe safest way. Generates numbers that are maybe a little bit bigger than we need, because we couldn't do this. We could take the 27 and the 3 and say, well, they divide, gives me 9. 2 times 9, same 18. If you understand that, you can do that. Otherwise, I would say make it 54 and then divide 54 by 3. Yes. All right, so we get to some scenarios like this that ask you, can you write an expression? Once you write the expression or equation, can you then evaluate it? Okay. Here it says in football, a touchdown is worth 6 points. An extra point is worth one point. A field goal is worth 3 points. Okay, so that's the structure of the scoring system in football. Okay, so what algebraic expression models the total number of points that a football team scores in a game, assuming each scoring play is one of the three given types? Okay, so suppose a football team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. Okay, so let's do this. Let's say, now they give us our variables here. Now, your variables are just, they're symbols. We said we're always going to let them be like lowercase letters out of the alphabet, but they don't have to be. They're just symbols. They could be, you guys, I don't know if I've mentioned this before. Like if I go like 3 plus blank equals 10, what goes in that box? 7, right? You guys remember doing that stuff in like the 3rd grade? Yeah. Okay. All right. My daughter is in kindergarten. She brought stuff home the other day that was asking this. Okay. We're like working with opposite numbers. So she started with like 3 plus, and then had a box and it says equals 0. So you guys have been, this is no different than what you guys experienced. I don't know if you can remember that back that far. But that's algebra, right? Isn't that the same thing there? Okay, so that box is just a symbol. So it can be anything. It can be a variable. It can be a shape. So I'm going to let touchdown be one variable. TD be a variable. E, P, K be a variable. And F, G be a variable. Does that make sense to everybody? Okay. Those are my variables that I'm going to use. Now, we can maybe do this using letters like X, Y, and Z in a little bit as well, and I'll show you how maybe that can kind of be a pain in the butt. But if I go TD, how many points did they say a TD was worth? 6. Extra point 1, field goal 3, right? Look at my team. How many touchdowns did my team score? Okay, so in my particular case, I'm going to have 3 touchdowns. And then they're going to add to that, how many extra points did they get? 2 extra points. And we're going to add to that, how many field goals? That's an expression to describe the total number of points that this team scored, right? Now, what was TD worth? 6. So when they write this phrase up here, they're telling you, kind of like the last ones that were said, like X was 5 and Y was 1/2, something like that. They're telling you how to replace these. So I'm going to go 3 times 6, replace EPK with 1, and then replace field goal with 3. So now order of operations, are there parentheses? Yeah, but is there anything I can do inside them? Nope. So are there exponents? Nope. Is there multiplication, division? Yes. So as I see them left to right, can I do them all at once? Yes, let's go ahead and do that. So 3 times 6 is 18. I'll then have plus 2 times 1 is 2. And 4 times 3 is 12. So I get 32. Okay. Now, you could have said X equals your field goals, or not field goals, touchdowns. Use any variables you want to. Y is extra point kicks, and Z is field goals. So then you would have written like 3X plus 2Y plus 4Z. But now I got to remember, okay, well, when I substitute, when I try to evaluate this thing, okay, I got to remember, well, what was X? Well, X was TD was 6 points. Now I got to go 3 times 6, right? But if I use variables that are more descriptive, I know, because it's just my experiences, touchdown is 6. I automatically know that. So when I see TD, I'm going to replace it with 6. I don't have to keep cross-referencing back to other variables that I've introduced. Does that make sense to everybody? Whether you use that structure or not is up to you, but I think it's a good idea. Just some key terms before we get out of here. A term in algebra is just a number, a variable, or a combination of a number and a variable. So everything we've been doing with, if I just look at like 3x plus 2y plus 4z, that's an expression. But each of those individual things that is separated by a plus sign is referred to as a term. Okay? So we're going to have, that is a term. 3x is a term. X is a term. Does that kind of make sense? Is 3x plus 2y, is that a term? Is 3x plus 2y a term? No. Okay? Terms are not going to have plus and minus in them. They could have multiplication or division, but they're not going to have plus or minus. So 3x by itself is a term. 2y by itself is a term, but their sum, 3x plus 2y, is not a term. Okay, just vocab that we have to set up so we can have a conversation about certain structures of expressions and equations. A constant, what's constant mean? Yep. Okay. So constant is something that never changes. So our numbers are constant. Okay. Something that is non-variable. It does not have a variable with it. Okay. So 3, 5, 12, pi. Those are constants. Okay. Coefficient, that's the number in front of the variable, right? Okay. So if I go like 3x, 4y, 12z, okay, the 3 is the coefficient. Okay. Our structure, for the most part, we always write our coefficients out in front for most things. There's a couple things as we work through the year where the coefficient will be in the back, but we'll talk about that later. Like terms are terms that have the same exact variables and the same exact exponents for those variables. Okay, so if I write like 3x and 12x, do they have the same variable? Do they have the same exponent of 1? That's an example. So what if I go 3y squared z and 5 z y squared? Do they both have a y squared? Do they both have a z? Yeah. Okay. The order doesn't matter because it's multiplication, so you can move them around using the commutative property. But that then is a set of like terms. What if I go black? What if I go 5xy and 6xy squared? Are those like terms? Why? Because one's squared and the other one is not. Okay. There will be a homework 1-3 posted due on Friday. All right. See ya. All right.